We're on problem 76. It says one bag contains 2 green marbles and 4 white marbles. Okay, so that's one bag, and we have 2 green and 4 white. And a second bag contains 3 green marbles and 1 white marble. Okay, so the second bag and has 3 green and 1 white marble. If Trent randomly draws 1 marble from each bag, what is the probability that they are both green? Okay, so what's the probability that he draws a green marble from this first bag? Well, let's see. There's 2 green marbles out of a total of how many marbles? 2 plus 4 marbles. There's a total of 6 marbles in here. So there's a 2/6 or 1/3 chance that he draws a green marble out of this bag. And then when he goes to this bag and says, okay, how many green marbles are there? Well, there are 3 green marbles out of a total possibility of 4 marbles, right? So there's a 3/4 chance that he picks a green marble out of this bag. So the chance that he picks a green marble out of both bags is just the 2/6 times the 3/4. That's 1/3 times 3/4, which is equal to a 1/4 probability. The next question. I decided that it's fast when I pre-cut and paste the questions. It took me like 18 videos to think of that innovation. Anyway, a box contains 7 red marbles. No, 7 large red marbles. 5. Okay, let me see. I have a box. I have 7 large red marbles, 5 large yellow marbles, 3 small red marbles, and 5 small yellow marbles. If a marble is drawn at random, what is the probability that it is yellow? So probability that it is yellow, given that it is one of the large marbles, given that it is large. Okay, so this might seem difficult, conditional probability and all of that, but all you have to think about is, okay, we've picked a marble out of the box, and it's large, right? So if I have a large marble in my hand, what is the probability that I picked a yellow large marble? So the easiest way to think about it is just think about the universe of large marbles, right? We picked one of these 12 marbles here. We picked one of the large ones. So we definitely picked one of these 12 marbles. And so what are the probability that I picked a yellow large marble? So there's a total of 5 yellow large marbles, right? That's what they want to know, right? Given it was one of the large, probability yellow, right? So there's 5 yellow large marbles. That's these right here. And how many total large marbles might I have picked? Well, 5 plus 7 is 12. So there's a 5/12 chance that I picked a yellow marble, given that I picked one of the large marbles. Next question. There's a trash truck outside making a lot of noise. Hope you don't hear it. Anyway, this was a big diagram. Let's see. Jamie will definitely try out. This is what, problem 78? Let me switch to a dark color because I'm going to be writing on white. Jamie will definitely try out for either basketball or baseball. Okay, basketball or baseball, but not both. The probability that Jamie will try out for basketball and try out, I need to learn to read. The probability that Jamie will try out for baseball and try out for catcher is 42%. So this probability is 42%. Right? Baseball and catcher. What is the probability that Jamie will try out for basketball? Okay, so what have they provided us? There's some probability that Jamie tries out for basketball, some probability that Jamie tries out for baseball. Let's just assign some, let's say that this is x, because that's what we want to figure out. And if that probability is x, then the probability of trying out for baseball is just going to be 1 minus x. Right? If that's 60%, this is going to be 40%. I don't know what it is yet. But then they say if Jamie is trying out for basketball, then there's an 80% chance that he tries out for guard and a 20% chance for forward. But if you said what's the probability that he does basketball and forward, it would be x times 20%, right? Maybe there's a 50% chance he does basketball, and then there's 20% of those times he would be a forward, so it would be a 10% chance. So we do the same logic here. If he tries out for baseball, there's a 70% chance that he'll try out for catcher. And they already told us that the combined probability, the probability that he'll try out for baseball and given that try out for catcher, that is 42%. So we can write that 1 minus x 1 minus x, right? That's this probability, times 70% times 0.7 is equal to 42%, which is 0.42, right? And then you get 1 minus x. 1 minus x is equal to what? What's 0.42 divided by 7? Let's see. It's same 42 divided by 7 would be 6. 0.7, right? So it would be 60%. 60%. And you could do that division. And it's always good to do a reality check and say, okay, 70% of something is 42%. Okay, 70% of 60%, yeah, that makes sense that it would be 42%. And just in case you don't make a decimal mistake. So 1 minus x is 60%. This is a 60% probability right here, going down this chain. And so now maybe you can see it a little more concretely. We said, okay, whatever this is times the probability that he tries out for catcher, given that he's trying out for baseball team, that's going to be equal to 42%. Then we figured this out. Now, if this is 60%, 1 minus x, then x is the 1. If this is 60%, x is 1 minus that. So x is 40%. Now, we could have actually solved for it. We could have actually said 1 minus x is equal to 60%. And then you could have said, I don't know, minus x is equal to minus 40%. Right? Subtract 1 from both sides. X is equal to 40%. But anyway, that's what the question they asked us. And let's see, what choice was that? What choice? Well, it doesn't matter. Let me have the. You see, what choice was that? That was choice A. 2 problems left. I'm going to be nostalgic for these California Standards Algebra 2 exams. All right, let me copy and paste this one in. All right, a small business owner must hire seasonal workers as the need arises. The following list shows the number of employees hired monthly for a 5-month period. If the mean of these data, data is a plural. If the mean of these data is approximately 7, what is the population standard deviation for these data? Round the answer to the nearest step. Okay, standard deviation has all sorts of definitions. Well, there is one definition for it, but I just always think about it as it's the average distance from the average, or it's the average distance from the mean. And if you wanted a visual kind of representation of it, let's say that I were to draw, let me say this is some type of y-axis there, and this is some type of, and on the x-axis I were to draw each of the data points, right? So this is data point 1, this is data point 2. You wouldn't have to do this on the problem, but I really want to give you an intuition for what the standard deviation is so that you don't forget it when you're 32 years old. All right, so we have a couple of, so the data points go all the way from 4 to 13. So let's see, data point 1 is 4. Let's say that this is 4. I just want to give you a, so that's 4. Data point 2 is 13, so maybe 13 will be up here. Data point 2 is 13. Data point 3 is 5. Yeah, that's right around there. 5. Data point 4 is 6. Maybe it's right there. And data point 5 is 9. So maybe 9 is, I don't know. I'm just eyeballing it. Maybe 9 is right there. Okay. And they're telling us that if we average these numbers, our average is 7, right? So 7 is our average. So if this is 7, right? And I'm just, let's see. So the average is 7. And they didn't have to tell you that. They're just trying to save you some time. You could have added all of these numbers up, and you said, okay, I got 7. I'm guessing that we get some decimals or something. That's why they said approximately 7. But anyway, that's the average. So the the standard deviation is just the average distance from the average, or the average distance from the mean. So what you say is, and you might know it as the square root of variance and all of that, and the variance is just the square of the distance from the mean. So, well, and they just really square it so that it stays positive. But if you just say 4 and 7, what's the distance between 4 and 7? Well, I'll draw it with my marker. The distance between 4 and 7 is 3, right? Remember, we just want to figure out the distance. We don't want to know which one's bigger. 4 is 3 away from 7. So that's why sometimes people will say, oh, okay, the variance is equal to, 4 minus 7 squared, and then that'll give you, right, 9. And then they will say that the standard deviation is equal to the square root of the variance, right, which is equal to 3. But you could have just said that the standard deviation is equal to the absolute value of 4 minus 7. Because that's really, and to me this is more intuitive because we're just saying, okay, how far away is it from 7? I don't care if it's above or below. I just want to know the distance from it, and then I just want to average each of those. Oh, and sorry, this isn't the standard deviation itself. This is each of the terms, and then we would average them. Anyway, let me erase this because I think I'll need that space. The standard deviation, you figured this out. You take the sum of these and then you average them. I'll show it to you in a second. Let me erase this. I think the proper notation would have been, actually let me do it. So the proper notation you could have written as the standard deviation is equal to the sum of the differences of the data points. There's n data points, the n data points, and that we want to take the absolute value between each of the data points. So, data point I minus the mean, right? What do they write mu for the mean or something? They always use, it gets complicated. So that's the sum of all of them, and then you want to divide that by n. So essentially you're taking the average distance from the mean. All of that might be really complicated. You could have written variance. Well, anyway, I just want to show you that when you do the statistics class, it'll introduce you to a lot of things, but at the end, all you care is the average distance from the mean, and I'll show you how easy that is to calculate. Everything I've done so far in this problem, you would not have had to do on a real exam. I'm just trying to give a little bit of intuition. All right, so the distance from 4 to 7 is 3, right? So the distance from data point 1 is 3. The distance from 13 to 7, what's that distance? Well, that's 7, right? We just care about the absolute distance. So then that distance is 7. The distance from 5 to 7 is 2. This is a 2. Distance from 6 to 7 is 1. Distance from 9 to 7 is 2. So we just want to take the average of all of these numbers. So let's see. 3 plus 7 is 10. 10 plus 2 is 12. 12 plus 1 is 13. Plus 2 is 15. So the sum of these is 15. And I have 5 data points, so divided by 5 is equal to 3. So the standard deviation is equal to, well, that's strange because I got 3, and they have an answer called 3.3. So I feel like maybe I made a mistake, but I mean, I'm going to go with that. I'm going to go with the 3.3. Maybe. I guess I think the actual mean is probably not 7. So if you used the non-actual mean, you would have, let's see what the actual mean is. And once again, this is not something that you would have to do. Well, anyway, actually, I just realized I've run out of time. So I'll continue this in the next video. See you soon. The next video is going to be one problem.